Hey guys, so section 8.4 is all about angles of elevation and depression. So before we truly get started with this, let's make sure we know what angle of elevation and angle of depression mean, right? What they are. So the angle that's formed by a horizontal line and a line of sight to a point that's above the line is your angle of elevation. All right, so for example, looking over here at this picture, we've got this plane tower, right? A tower, and we have a plane all the way up here. So from the tower, we've got this horizontal line that's out, okay? So out from the tower, and we are going up to the airplane. That means that that angle 1 right there is an angle of elevation from the tower to the plane. Right? The people in the tower are here and they're looking up towards the plane. So that angle that's formed is an angle of elevation. Okay? Angle of depression then should be pretty straightforward. The angle of depression is the angle formed by a horizontal line and a line of sight to a point below the line. All right, so taking a look at this same picture, but now from a different aspect, right? Now we're talking about being up in the plane. So the plane is flying this course, right? That's horizontal here. And now the people in the plane are looking down to the tower, which means that angle that's formed there is an angle of depression because we're going down from the plane to the tower. Okay, angle 2 then is the angle of depression from the plane to the tower. So something pretty cool happens when we talk about angles of elevation and angles of depression. Since horizontal lines are parallel, angle 1 is congruent to angle 2. So those two angles that we just talked about, they're congruent to each other. And that's by the alternate interior angles theorem. All right, remember back to chapter 3 where we did if parallel lines, then alternate interior angles are congruent. Well, if we take a look at that picture, even if we just look at the second one, here's the course that the plane is flying, right? That's a horizontal line. Here's the horizontal line straight out from the tower, and the line between them is your transversal. So it's pretty clear that angle 1 and angle 2 would be congruent to each other. All right, so essentially what this is saying then is that the angle of elevation from one point, oops, let's move that over, there we go. The angle of elevation from one point is congruent to the angle of depression from the other point. Okay, so it's pretty cool that we get those to be congruent to each other. We just have to be careful that we're talking about the right angles. Okay, so sometimes drawing these pictures can get a little nasty, but we will worry about that in a minute. Okay, so taking a look at the next page, we're going to classify each of these angles as an angle of elevation or an angle of depression. So taking a look at angle 1, here's angle 1 right here. Here's my horizontal line coming out and going down to here, which means angle 1 is an angle of depression. And it's an angle of depression from the top of that mountain to the hiker. So from the mountaintop to, and we're just going to call him a guy, all right, to the guy that's there. So from the top of the mountain to the guy. We're looking down, that's an angle of depression. Okay? Then if we're looking at angle 2, well, here's the horizontal from angle 2. And we're actually going to use that same line going up, which means angle 2 is actually the angle of elevation from that guy, from the hiker, to the top of the mountain. All right, and if we look, that kind of makes sense. Those two horizontal lines are parallel to each other, which means angle 1 and angle 2 are congruent. And it would make sense then that they're going from the mountaintop to the guy and from the guy to the mountaintop. But one's a depression, one's an elevation. Okay? Taking a look at angle 3 then, we've got that same line of sight, right? This guy's looking straight out, but now he's looking down to the house here, which means angle 3 is an angle of depression. And it's from the guy to the house. Okay, or to the ground next to the house, however you want to word it is fine. And then the last one, angle 4, here's the horizontal, which is actually the ground. And here's the line of sight going back up to this guy. So that one is going up. That one is an angle of elevation. And it's from the house to the guy. So again, the opposite of number 3. Number 3 was depression from the guy to the house because he's looking down. And then angle 4 is the angle of elevation because it's from the house up to that guy. All right, that H kind of looks like a B, so let me fix that. My bad, guys. Okay, so moving right along. So we're going to take a look at how to solve these angle of depression and angle of elevation word problems, okay? Everybody always struggles with word problems, so we're going to make a list for ourselves to kind of go through. So first thing we're going to do is draw a picture to represent the situation. And this picture is going to create a triangle, right? Think about what this chapter is all about. This chapter is all about trigonometry. And we're using trig in right triangles, which means that's what we're going to have to make, right? Then we're going to determine the appropriate trig function that we need to use. We're going to set up an equation, and we're going to solve it. Okay, pretty straightforward. Draw a picture, figure out what trig function you need, and then set up an equation and solve it. Once we get the picture down, you guys will be just fine. All right, it's drawing the picture that's a problem. So, number 1. You see a rock climber on a cliff at a 32-degree angle of elevation. So I'm going to go ahead and highlight that real quick. The horizontal ground distance to the base of the cliff, so horizontal ground distance, is 1,000 feet. All right. How high is the rock climber above the ground? So that's what we're looking for there. That's the unknown, is how high up is he? Okay. So we have to think about what this is going to look like. All right. So here's you as a person. Okay. Lovely little guy right here. And you're walking along, okay, and you are standing 1,000 feet from the base of this cliff, okay, and you see a rock climber up here. And he's climbing this cliff. So this is you, that's the rock climber. And we know that the angle of elevation is 32 degrees. Well, it's the angle of elevation from you to the rock climber, which means this is your 32-degree angle. All right. And the rock climber is straight up. He's 90 degrees, which means we just made a right triangle. And the distance that we're looking for is how high up is the rock climber off the ground. Well, the distance from the ground is this perpendicular height here. Okay. So we're looking for x. Now it's just a matter of, now that we've got the picture, we're just looking for which trig function do we need to use. So this you guys should be pros at by now. Here's our angle. And the side across is what we're looking for. That's the opposite. And we were given the adjacent, which means we're going to need to use tangent. So the tangent of 32 degrees is equal to the opposite side over the adjacent. So x is going to equal 1,000 times the tangent of 32. All right, you should be able to solve that no problem now. You guys took a quiz on that already. We're going to round to the nearest tenth of a foot. So let's go ahead and put this into our calculator. So 1,000 times the tangent of 32, and we get 624.869. We want to round to the nearest tenth, which means x equals 624.8, oops, I want to round to the nearest tenth, Miss J. So 0.9, and then feet. We don't want to forget our units. Okay, so tenths place means one place after the decimal. Sorry, I'm used to rounding to the hundredths. So 624.9 and then feet, because that was what our distances were in. Okay, taking a look at question 2. So a pilot of a plane is flying at an altitude of 2,714 meters. That's his altitude. His angle of depression as the plane descends is 3 degrees. How far away from the runway is the airplane? All right, so we're going to say that the airplane is up here, okay? And we know that his altitude is 2,714 meters. And the plane is descending to the runway. All right, so this is the ground over here. Altitude is measured at a perpendicular distance. So there's my triangle, but what I have to figure out is where my angle of depression goes and which side I'm looking for. So I know that the airplane, if it wasn't descending, would be going straight out at this horizontal, that pink dotted line I just drew in, right? So the angle of depression then, that's this angle out here, is 3 degrees. Okay? Well, that 3 degrees is not inside my triangle. So I'm going to have to use the fact that I know these two lines are parallel to each other, which means my 3 degrees is actually down here. All right, so be careful. Don't put it up here in the top corner, because that's not where it is. The plane has a horizontal out here and a line of sight down. That's your angle of depression, which means it bounces down here. Okay. Then we're looking for how far away from the runway is the plane. Well, the plane is here, and the runway is down here, which means the distance we're looking for is right there. Okay, and now it's just trig to solve it. So here's my angle across from that. That means this is my opposite. Across from my 90-degree angle is my hypotenuse. And I know that opposite and hypotenuse is going to be sine. So the sine of 3 degrees is going to equal the opposite over the hypotenuse. And hopefully you guys are okay with solving that too. And I can just jump right to 2714 over the sine of 3 degrees. And I'm going to put that on my calculator. This time I'm going to round to the nearest meter. So I'm going to do the nearest whole number. So 2714 over the sine of 3 and I get x equals 51,857, and we're talking about meters in this case, which means that the airplane is 51,857 meters away from the runway. All right. When you do these problems, all of this has to be included. The labels here, right? The initial angle, your other angle here, all of your work, and then your answer with a unit. If you don't have all of that, you will not get full credit. I'm telling you right now. Okay, so don't come crying to me later if you guys missed stuff because you weren't listening. All right, so if you had questions, please write them down. These can get tricky. So make sure that you understand what's going on, okay? And I will talk to you guys in class. All right, bye.